Hello children, let's do few more sums on trigonometric equations. The sum is on your screen. Tan theta plus tan 2 theta plus root 3 tan theta into tan 2 theta is equal to root 3, and we have to find a general solution. We have to find a general solution. I am seeing tan theta, tan 2 theta, tan theta, tan 2 theta in both the things. So what I am going to do is, this you will have to observe, and once you observe this kind of question, you will be able to apply the same thing in the same kind, this kind of manipulation you will be able to apply into other questions as well. Tan theta plus tan 2 theta is equal to root 3. If I take common 1 minus tan theta and tan 2 theta. This is the question which we had. This is the question which we had, or we can write it as tan theta plus tan 2 theta upon 1 minus tan theta tan 2 theta is equal to root 3. If you look into this left hand side carefully, it is tan A plus tan B upon 1 minus tan A tan B. Tan A plus tan B upon, it is of the form tan A plus tan B upon 1 minus tan A tan B. Instead of A you have theta, instead of B you have 2 theta. Instead of A you have theta, instead of B you have 2 theta. So what you will get is tan theta plus 2 theta actually. It will become tan theta plus 2 theta is equal to root 3, or tan 3 theta will be equal to root 3, which is tan 60. Tan 60 pi by 3. And what is the general solution for tan? Theta becomes n pi plus alpha. N pi plus alpha. So here 3 theta will be equal to n pi plus pi by 3, or theta will be equal to 1 upon 3 n pi plus pi by 3. This is your general solution. This is your general solution for this kind of equation. So you need to observe, and obviously there will be many questions based on the same, and we have to observe the trick that how do we manipulate, and once we manipulate it nicely, we know what to do. Now let's see the next sum. This is cot theta plus tan theta. Theta plus tan theta is equal to 2 cosec theta. Now tan theta is also there, cot theta is there, or cosec theta is also there. We can convert everything in terms of sine and cos. Cot theta can be written as cos theta upon sine theta, tan theta can be written as sine theta upon cos theta, and cosec theta can be written as 1 upon sine theta. So we will write it as cos theta upon sine theta plus sine theta upon cos theta is equal to 2 upon sine theta. 2 upon sine theta. So what will happen? It will be cos square theta plus sine square theta. We have taken sine theta and cos theta as LCM. Sine theta and cos theta is LCM, and it is 2 upon sine theta. Now cos square theta plus sine square theta is 1, is equal to 2 sine theta cos theta upon Sine theta. So sine theta can cancel, and what will I get? I'll get 2 cos theta is equal to 1, or cos theta is equal to 1 upon 2, which is cos 60 pi by 3, which is cos pi by 3. So theta will be, because it is cos solution, 2n pi plus minus pi by 3. This is the general solution for this particular quadratic equation. 2n pi plus minus pi upon 3. Let's see another question. Two cos theta plus cos 3 theta is equal to 0. It's mainly application of actually your formulas. 2 cos theta, then I am saying plus cos 3 theta is 4 cos cube theta minus 3 cos theta is equal to 0. Cos 3 theta is 4 cos cube theta minus 3 cos theta. So what will it become? It will become 4 cos cube theta minus cos theta. 2 cos theta minus 3 cos theta is cos theta. Cos theta can be taken out as common, and what will be left here? It will be left here 4 cos square theta minus 1 is equal to 0. So 1 is cos theta will be equal to 0. Cos theta is equal to 0 means theta will be an odd multiple of pi by 2. 2n plus 1 pi by 2. This is one solution. This is one solution. Now second is 4 cos square theta is equal to 1, or cos square theta will be 1 upon 4, or cos theta will be plus minus 1 upon 2. So we'll get the values in all the 4 quadrants, because it is coming plus minus. It is coming plus minus. That means it will have to, it is square, cos square theta. So what will be the value? Will be cos theta. Theta will be how much? 2n pi plus minus pi by 3. Plus minus pi by 3, with the value of n belongs to set of integers. N belongs to set of integers. So with the change of n, you will get different values. Why I am saying it will come in all the 4 quadrants? Because we are looking for a general solution. For example, if we are looking for a principal solution, for example, just look at this. If I had drawn this figure, and we are saying theta is pi by 360 degree. So this angle, this angle, this is 60 degree, this is 60 degree, this is 60 degree, this is also 60 degree. Because cos is positive in the first and the fourth quadrant, and it is negative in the second and the third quadrant. So the value corresponding to second, third will come also, which is minus 1 upon 2. So actually if you look into the principal solution, it is 60 degree. 180 minus 60 will be 120 in the second, which will give you minus 1 upon 2. 180 plus 60, 240. Cos 240 is minus 1 upon 2, which will be in the third quadrant. And 360 minus 60, 300, which will be in the fourth quadrant, which will be positive 1 upon 2. So we are talking, but we are talking of general solution. That is why we said plus minus pi by 3. Add also pi by 3, subtract also pi by 3 from, because it is a periodic function. So after every 2 pi, it will repeat itself with the change of values. We will get general solution. Now let us see the next question, which is 2 sine 2x minus sin x is equal to 0. Again we have to find the general solution. Again this is just application of formulas actually. 2 into 2 sin x cos x. Sin 2x is sin x cos x minus sin x is equal to 0. The necessity of doing so many questions, not for me but for you, would be that if I am going to do these many questions, maybe you also start doing that many questions and you remember the application. Sin 2x, cos 3x, tan 3 theta, all these formulas will keep repeating in questions, and more you apply it, more you will learn it. For sin x, cos x, and besides that explanation of this all the time in the first, second, third quadrant, how the values are coming, it is very important. Basics are very important for you to understand. Basics are very important for you to understand. You must understand the basics. You must understand the basics. Okay, now let's take sin x common. If we take sin x common, we'll get 4 cos x minus 1 is equal to 0. So number 1, sin x is 0. That means x is equal to n pi. X is n pi. This is a special case. This is a special case. Because sin x is 0, x will be n pi. Now 4 cos x minus 1 is equal to 0. That means 4 cos x is equal to 1. Or cos x will be 1 upon 4. Cos x will be 1 upon 4. So x will be equal to 2n pi plus minus, it will be cos inverse 1 upon 4. Cos inverse 1 upon 4. Or sometimes people write it like this, that 2n pi plus minus alpha, where alpha they will say is equal to cos inverse 1 upon 4. Whichever way you prefer it, that is okay. There is no problem. Some people write it this way, 2n pi plus minus alpha, and write the value of alpha separately as cos inverse 1 upon 4. But I am writing directly, so it doesn't really matter. Whether you write it directly or indirectly, it doesn't matter. Now let us see tan 2x plus 2 tan x is equal to 0. Again I am saying time and again, what we are doing is we are applying different formulas. Like it comes tan 2x, so we'll have to apply tan 2x formula, which is 2 tan x upon 1 minus tan square x. We will tend to forget if we do not do the practice and do not apply or do not remember these formulas. The looking into turning back pages or a particular page in your notebook is not going to help during the examination, because that notebook will not be allowed inside the examination hall. You need to remember these formulas. You need to learn. Okay, 2 tan x, when we have taken the LCM, it will become 2 tan x and 1 minus tan square x is equal to 0. Is equal to 0. Now 2 tan x I can take that common. I can take that 2 tan x common. 2 tan x is here also. 2 tan x is here also. So 2 tan x can be taken out common. It will be left with 1 plus 1 minus tan square x is equal to 0. So number 1, 2 tan x is equal to 0, or tan x is equal to 0. That implies x is equal to n pi. It is the same as for sine. For sine also, sine is 0 on the horizontal line. Similarly, tan x is also 0 on the horizontal line. Tan 0 is 0. Sine 0 is 0. And second one is 2 minus 10 square x is equal to 0, or 10 square x is equal to 2. So 10x will be plus minus 2. Again, what will happen is this value will come as what? X is equal to n pi plus minus 10 inverse 2. You had noticed that when we have cos and sine coming as 2, when we had sine and cos coming as 2, sine square x is equal to 2, or we had under root 2, sorry, this will become under root 2. So then we were saying if 10x was, sin x was coming equal to 2, we used to say it is not possible because the range of sin x and cos x is between minus 1 and plus 1. But for 10x, there is no this kind of restriction. Now let us see next question. 7 sin 7 theta plus sin 4 theta plus sin theta is equal to 0. Again, general solution. Again, we have to apply sin c plus sin d. We have to apply sin c plus sin d for this. Like, it will become sin 7 theta plus sin theta. I will combine. I'll tell you why I am combining them and not with sin 4 theta. You see, sin 7 theta plus theta will become 8 theta. 8 theta divided by 2 will give me 4 theta. So I will be able to take 4 theta common. If I combine 4 theta plus theta, it will become 5 theta upon 2. I am not interested in half angles just now. And 7 theta will be left it is. If I combine 7 theta plus 4 theta, it will become 11 theta. Again, it is not divisible by 2. So I am not interested. I am interested where it becomes simpler. Your effort should be to see that things become simpler for you. Things become simpler for you. Like it will be 2 sine 7 theta plus theta upon 2 and cos 7 theta minus theta upon 2 plus sine 4 theta is equal to 0. I'll obtain 2 sine 7 theta plus theta will become 8 theta. 8 theta divided by 2 will give you 4 theta. So 2 sine 4 theta. Cos 7 theta minus theta will be 6. 6 will be divided. Again, I get 2 3s are 6. Plus sine 4 theta. So I am getting at least, I am not getting anything in the denominator. I am getting simplified terms. Now I am able to take sine 4 theta as common, and it will be left with 2 cos 3 theta plus 1 is equal to 0. Number 1, sine 4 theta is equal to 0. Sine 4 theta is 0, that means it is 4 theta will be equal to n pi, because when sin theta is 0, you get theta is equal to n pi. Here 4 theta, sin 4 theta is equal to 0, you will get n pi, and theta will become n pi upon 4. This is one of the solutions. Now 2 cos 3 theta plus 1 is equal to 0. So 2 cos 3 theta will be equal to minus 1 upon 2. Minus 1. It will minus 1, and cos 3 theta will become equal to minus 1 upon 2. Alright, it is minus 1 upon 2. So actually pi by 3. It is pi by 3. So we'll write 3 theta is equal to 2n pi plus minus pi upon 3, and theta will be 2n pi 1 upon 3 plus minus pi upon 3. Okay, let us see the question number Actually, it is coming minus 1 upon 2. It is coming minus 1 upon 2. So minus 1 upon 2 will be here. It will be pi minus pi upon 3. That will be 2 pi upon 3. So it should be 2 pi upon 3. 2 pi upon 3. It should be 2 pi upon 3. 1 upon, you can take 2 common 3, n plus minus 1 upon 3, and pi can be taken out. That's right. Okay, now let us see the next question. This will be the last question here. Cos theta plus cos 2 theta plus cos 3 theta plus cos 3 theta is equal to 0. Is equal to 0. So what are we going to do here? Now again we will have to be careful. I'll choose cos theta plus cos 3 theta. I'll combine, because 2 theta, if I combine 2 theta plus theta, will become 3 theta divided by 2. I don't want anything in denominator, so I will make the combination of cos theta, cos 3 theta and plus cos 2 theta is equal to 0. So I can write 2 cos c plus d upon 2 and cos c minus d upon 2 plus cos 2 theta is equal to 0. It will become 2 cos 2 theta. 3 theta plus theta is 4 theta divided by 2 will give you 2 theta, and cos theta plus cos 2 theta is equal to 0. I can take cos 2 theta as common. It will be left 2 cos theta plus 1 is equal to 0. Number 1, cos 2 theta is 0, means 2 theta will be 2n pi, 2n plus 1 pi by 2, 2n plus 1 pi by 2, odd multiple of pi. 2n plus 1 pi by 2, so theta will be 2n plus 1 pi by 4. The first solution will be this, 2n plus 1 pi by 4. Second solution will be 2 cos theta is equal to minus 1. Cos theta will be minus 1 upon 2. We just did that. Here I will say it is going to come in second and third quadrant. So what are we going to do? We will say theta is equal to 2n pi plus minus pi minus pi by 3. So 2 pi by 3. 2 pi by 3. 2n pi plus pi by 3. So this is the solution, and this is the solution. So that will do for the time being. Thank you.